Okay, so in this video, I'm going to talk about this recent paper where they tackled the International Physics Olympiad questions using Agentic Gemini. So they achieved an impressive gold medal level at the IPhO questions, just the theory side, using Google's Gemini 2.5 Pro model, just as you and I could use on the internet, plus an agentic system that they proved could boost the scores. So just to show the level of achievement we're talking about, I'll show the three main physics questions that were being answered, and then explain the agent system which they built, and along the way, I'll talk about my own Physics Olympiad experience. Okay, so what's the IPhO? This is the International Physics Olympiad, which is similar in spirit to the International Maths Olympiad. So this has taken place every year since 1967, and each country participating sends 5 of their high school physicists to like a central place where everyone competes in the main exam. So we're going to have a quick look at the 3 theory questions, and the people were given 5 hours to answer these 3 questions. They were about hydrogen and galaxies, a funky timepiece, and champagne. Now this competition this year was held in France, so I guess this is the French exam question. There were also 2 experimental questions which weren't attempted by the AI, kind of obviously. These were used physical equipment where you'd actually peer at droplets of water or something like that. But they have in the past done computer simulation experiments which could be possible via an agentic system. So the first of the 3 questions was about hydrogen and galaxies. And the very first part is a very simple model of the hydrogen atom and find out where it gives a special spectral line. So having got a spectral line from a hydrogen atom, we then move on to looking at how galaxies rotate. Now, these are all calculations that can be done using high school physics, but here they've got a very kind of exceptional setting which requires students to think out of the box. So it moves on to mass distribution within a galaxy and includes some tricky diagrams to look at and also some graphs to read measurements of. And finally, it moves on to Mond theory, which is an alternative way of explaining how galaxies rotate, which doesn't seem to be at the right kind of speeds depending on distance from the center, and is an alternative to kind of dark matter. This is kind of definitely not covered in high school physics, but the basic principles can be applied to get a feel for what's going on. And so that covers one of the 3 problems. The second of the 3 problems covers Cox's timepiece, which apparently was made in 1765 by a British clockmaker. Obviously this is in a museum, but the way in which it works is to do with having a tube dipped in mercury which moves up and down with air pressure. So there's a bunch of different things going on, and they look at the physics of a submerged tube, how this might work when you've got several pieces of a tube, and how this can be translated into becoming an actual working clock. And so they finish up with working out how this actual clock works when powered by the weather. Again, this is something which is understandable using high school physics, but almost certainly has not been covered in any lesson that anyone has had. Now for the third question, I guess we're on to the French question, which is all about champagne. And because it's high school students, I guess they had to put a warning on here about excessive alcohol consumption. And so this is split into parts, the first being about how bubbles start to form and how they grow and rise within the champagne. The second part is about how a bubble pops and makes a sound. And so you can also analyze this in terms of the size of the bubble and the rate of the popping. And so the final flourish on the exam is working out how high a champagne cork will pop. And so again, using high school physics, you can work out different circumstances that will appear at different temperatures when popping champagne. And the final part of this final question is how high the cork will pop in a fairly cold room. So what metrics do they use to mark this? Well, actually the IPhO questions have a fairly fixed rubric and scoring scheme, and the paper's team included a member who had also been an IPhO competitor and had marked exam papers. On the other hand, these kind of questions, it's fairly obvious whether someone has been able to see the trick behind the answer. And if they can't see it, they just won't get anything. Okay, so the actual paper is called Physics Supernova, AI agent matches elite gold medalists in IPhO 2025. This is using Gemini 2.5 Pro agentically, and they just ran their system 5 times on each of the questions. Now, the last author announced this on Twitter, but was kind of apologetic for only having solved the theoretical questions for the exam. So in his mind, without tackling the practical problems and therefore achieving gold on the entire IPhO paper, this is only worth a workshop paper. On the other hand, I see that for the IMO, huge labs which achieved worse results would rush out to major publications to get their work recorded, so it seems like a bit defeatist to say that this didn't achieve much. Okay, so here's a picture of the whole agentic system they're using. On the left-hand side, you can see they're using a manage agent which calls out to tools. And they have 3 tools mentioned here, but for the main results, they're only using an answer reviewer and an image analyzer. So in order to answer a question, what they do is they feed in the question to the manager and get it in a loop to think what it wants to do, actually take an action with the tool, then essentially reflect on whether that action has resulted in something useful and whether it can proceed to an answer or not, and then essentially go around in a loop until it's satisfied that it has a final answer. Now, the framework they use for all of this is small agents, and they use the code agent module as their basis for doing each of these things. And in the paper, they explained this is in a reason-act loop, whereas the actual code agents can do Python commands, and this is where it would be super helpful to look at the logs to find out whether actually any real Python was taking place, or whether it was just using this for the function calling. So as I said, the main tools it had was the answer reviewer and the image analyzer. They limited it essentially to 80 steps around this loop and 32k tokens output per question. So let's have a quick look at the main agent loop here. So the main prompt is, your task is to solve the problem part by part, step by step. Only after you have fished the whole problem should you call final answer. Never call final answer when there are parts left. So this is something which I find on Archive quite often when you go into the supplemental sections to look at the actual prompts. There are often syntax or grammatical errors in the prompts. I'm sure they meant only after you have finished the whole problem. They also include prompting about how and when to use the image tool, which is basically saying if you ever need to look at an image or ever need to measure something, you have to use the image tool. Clearly, the degree to which they're insisting on this meant that there were probably circumstances where it wouldn't have used the image tool and just relied on its native charm with images rather than calling the image tool explicitly. So this is something where having like a separation of concerns between your agents, you have to really enforce it. Otherwise, your main agent might just decide it needs to do everything itself. So the image analysis tool is again another instance of Gemini Pro, but with very specific instructions about here's the question, you're going to get this from this specific image. So here they've really narrowed down what an image analysis tool does, and that's useful, I think, so that it doesn't try and expansively answer the question on its own, rather than just passing the answer back to the manage agent. Now, the answer reviewer prompt here is basically instructing Gemini Pro to be as critical as possible of its own output. And here you can see that they're calling out every kind of mistake that it has to highlight: logical, mathematical errors, dimensional consistency, missing steps, incorrect sign conventions. There's a whole bunch of stuff which presumably they feel that these might be issues which Gemini kind of messes up on. And if you've played with any of these large language models, you'll know that they tend to be quite sycophantic, in that they'll say, you asked an excellent question with great insight, I love your perspective, all of these kind of things. And this is where having this kind of reviewer explicitly tasked with criticizing everything you say could be a way of defeating that sycophancy, essentially by applying it using the model on itself. But even if you're prompting the model to answer your own questions, what you might do is propose 2 solutions and get the model to critique both of them. That way, the sycophancy idea could cancel out from both sides. Okay, so let's see how this worked. So this is a qualitative analysis from the paper where they go through all of the different parts of the questions, which I already showed, and they look at how novel this would have been to really a high school student. So in a way, the first part, the Bohr model, that's a kind of a textbook example. But the other stuff starts to get more and more out of the box thinking, which is exactly where the Physics Olympiad is heading. In terms of computational difficulty, there's normally not that much tricky computation to do. It's more about the thinking. On the image side, they also look at, do we have to just understand the images or actually do some measurements? Though I have to say that even the measurements which had to be taken from graphs were not exactly rocket science. And so here are the results for the overall system, and I guess the bottom right corner is the most important thing. So here, out of a total 30 points available, 10 points for each question over the full 5 hours, Gemini Pro itself could get 21.4 with some error bars. They know about the error bars because they ran it 5 times. They also know that the human gold medalists had a median score of 22.8. And so by using their Agentic system on top of Gemini Pro, they've moved from 21.4 to 23.5, essentially bumping themselves up into the upper half of the gold medal winners, which is super impressive. So overall, the system is scoring 14th among the 406 contestants. Now this is after the national selection stage, so this is the top 5 people from each nation. There are 406 contestants. So one of the questions on Twitter asked about whether this system had been overfit on the 2025 questions. And the last author stated plainly that they only had $200 to do the whole experiment. And so this system was simply a YOLO experiment in that they built the system, they ran it 5 times, they didn't really optimize the prompts or cherry pick results. Now, as an aside, this doesn't really answer the question, in as much as if they had a budget of $10,000, would they have cherry-picked the results? I don't think so. Scientifically, they did the right thing by keeping themselves to just running it the 5 times to get their error bars, but basically running the system as it stood. On the other hand, I think it's very impressive that they did this using a budget of just $200, whereas the big labs tackling the IMO or the Informatics Olympiad, I'm sure had budgets way in excess of $200. It's also interesting to see that Gemini Pro, clearly trained with a huge budget, as a regular version could also score a low gold on the Physics Olympiad, and including an Agentic system was able to boost this even higher than the median gold human competitor. So a few personal observations. I believe that the host country kind of affects the style of questions. So I did the Physics Olympiad representing the UK in the UK and Germany quite a while ago. The UK questions were very much along the lines of proving things. So the questions would lead you to essentially deriving mathematical formula and extending this to a more general case. It fitted very well with the maths-heavy syllabus in UK schools. The German questions, on the other hand, would seem to me very much more like calculate how big this system has to be, what is the deviation of this. Basically, it seemed more like an engineering style, which may suit the German school system and the German direction for their physics tuition. So for this French exam, it seems that the questions were broken into lots of little pieces and there's quite a lot of hand-holding going on. On the other hand, these small steps led the students down a very long path into quite interesting areas of physics. So this isn't to say that some years are easy and some years are hard. It's just that some years will suit different styles of students to different degrees, and it may be this year's exam suited Gemini because of the style of the exam. Hopefully someone with more than $200 budget could use the same system on previous years to find out whether they got lucky this year or whether this was consistently good over time. The Physics Olympiad also contains this practical component, which is going to be very difficult for these systems to tackle until humanoid robots improve a great deal. On the other hand, even when I did the IPhO, one of the experiments was simulated, which would allow for agents to interact with the system. Typically, these are done as a kind of a black box interrogation, so this could work quite well, as long as these things could essentially think outside the box. So to wrap up, Gemini Pro kind of proved itself to be rather excellent, and when you combine that with an agentic system, it can even boost further. As a small aside, maybe the exam style was helpful, though that's kind of an open question. But one major takeaway from this was only a limited budget was required to achieve International Physics Olympiad gold standard. Anyone can go and use their code, run the system, maybe improve the prompts, try it on other exams. There's a huge scope for experimentation here. And as a final point, I would just say that having a system which is this capable shouldn't really deter anyone from wanting to enter the International Physics Olympiad. Clearly, high school students that are keen on physics might want to prove how good they are and essentially compete up through the ranks in their country. And then the top 5 get to compete in this international competition, which is a huge amount of fun for everyone. I certainly had a great time, but I also had a great time reading this paper and finding out how they had applied Agentic Gemini to the same task. So, thank you for watching this video. Obviously, the IPhO competition is a bit of a passion topic for me, and I was super excited to see this paper, so I just thought I had to talk about it. In future videos, I'm interested in talking about things like base models, reinforcement learning, maybe something about fine-tuning, quantization. There's so many topics to discuss. Please let me know in the comments what you'd like to see. I could also talk on agentic systems or diffusion models. The more comments I receive, the better that I can make future videos for you. Cheers.